Hello, this is Mr. Moss, and in this video we're going to be learning about points, line segments, rays, lines, and angles. These are geometry terms that you may be familiar with, but we're going to really learn quite a bit more about these different ideas. So I want to start off just by exploring the idea of some of these things. I'm going to draw something simple right here. We've got this, whatever this is. And I think a lot of us would say, oh, I drew a line on the page. And the truth is, yes, there's a line on the page. Any person would look at that and say, yep, that's a line. Except in the world of geometry, we really wouldn't look at that as a line. Really, we'd call that a line segment. Now you may be thinking, well, hold on a minute, a segment is part of something else. Yeah, we're going to learn about all these different terms in this video. But the idea that I want to show you is that all of these things, line segments and rays and lines, what they do is they connect different points. And a point is nothing more than a location on a sheet of paper or on a wall or on a map or on a whiteboard, whatever it happens to be. So I've drawn a point right here. It doesn't have any shape to it. It doesn't have any size to it. It's just a location. So here's a point. I'm going to label it point A. And here's another point. I'm going to label it point B. You may notice that that dot happens to be bigger than that dot. It doesn't matter. It doesn't mean point B is any bigger because, again, points have no size. They have no shape. They're just locations. And whether you're talking about a line segment, a line, or a ray, something really important for you to know is that they go straight between 2 points. So right now, I'm going to use a ruler to connect them. It's straight between 2 points. It's in fact taking the shortest route between those 2 points. And of course, a straight line or a line segment or array will do that. If I drew 2 more points here, let's call this point C and point D, I could draw this, but this particular shape is neither straight nor is it the shortest distance between these 2 points. I'm taking some extra detours. So the rule is twofold. Number one is that it's the shortest distance between 2 points. And number two is that it is straight. So right over here, what I called a line before is really what I'd call a line segment. All I need to do is add some endpoints to it. So let's call these points E and points F. Let's learn a little bit more about specifically what a line segment is. A line segment, as we learned about, is straight and it connects 2 points, but it has 2 end points. It has a start and a stop. So for example, if I make points, let's see, what did I leave off before? E and F. So let's make this point G and point H. I can connect these right over here. And you can see now that I've drawn a line segment. It's straight, it connects 2 points, and those are endpoints, meaning it doesn't continue on in this direction, it doesn't continue on in that direction. It has a beginning and an end. We don't really know which is the beginning, which is the end. It doesn't matter. The idea is that both of these are endpoints. And I can write the name of this in 2 particular ways. I could either call it line segment GH, and I put a little line segment over it, or I could call it line segment HG. And again, I could put a line over it. That's our system of naming these particular figures. I can draw another one here. Let me draw 2 more points. We'll call this point I and point J. You'll notice that a line segment can go in any direction on my paper. I can have it go kind of across. I can have it go kind of up and down, but you'll notice neither of these are perfectly across or perfectly up and down. They're both going on a diagonal. And so again, I can name this point line segment IJ. It's supposed to be capital I. I'm running out of ink here. Or line segment JI. And the idea is that since neither has a beginning, neither is officially the beginning or the end, they're just endpoints. I could go in either direction. I can call this HG or GH. I can call this IJ or JI. It really doesn't matter how I choose to identify it. It's going to be clear to everyone. Let's do one more. Sometimes they can be really, kind of intermediate in length. They can go, like I said, at a diagonal. I can have a really short line segment right here. I can connect my points and call this point K and point L. So it's a really short line segment. And again, I can name this line segment KL or line segment LK. Or finally, I could have a really long one that stretches across the majority of my page. Remember, this isn't a line segment yet, however, because what's this missing? It's missing some points, those end points, the beginning and the end. M and N. And so I can name this line segment, not L, we already used that, line segment MN with my little line segment over it, or line segment NM, again with a line segment over it. So that's what a line segment is. And believe it or not, line segments are really common to spot in the real world.
Let's take a look at some real-world examples of line segments. Here's one good example here. I've got a yardstick. You'll notice that it's straight, that it goes from one point to another point, so it has a beginning and an end, and I can't really bend it. It is perfectly straight. This is a line segment. Here's another example, a little bit on the smaller side. I have a pencil. Again, it has a beginning and an end. It's straight. It connects those 2 points. And by the way, it could be a line segment if I hold it this way, if I hold it this way, if I hold it this way, even if I hold it facing you or with the tip facing you or the eraser facing you, it's still a line segment no matter how I hold it. Let's take a look at this right over here. I have a spring. You can see it's straight, it connects 2 points. In fact, you can even see some loops on either side. They're really good at being able to visualize the idea of 2 points that we're connecting. This is a line segment, except, now it's not straight anymore. So is this a line segment? Nope. I could take it, I could twist it. It's certainly not a line segment now that I tied a knot in it, but as soon as I return it to its normal resting shape, again, I have a line segment. Uh-oh. I think Darth Vader might be coming. I better get ready to protect myself. Okay! Once again, I have a line segment. It starts over here. It ends... Ooh, that's hot. Sorry. It ends right over here at the end. It's straight. It connects these 2 points. And again, whether I hold my lightsaber this way, or this way, or this way, or this way, or this way, either way, it is a line segment. Here's another example for you. I have here a bendy straw. Well, this is a line segment. It's connecting both. It's a line segment until I bend it. Now, not a line segment anymore. Of course, we could call this part a line segment, or we could call this part a line segment, but this whole thing, not a line segment. I do have, however, an angle. I've connected, in this case, 2 different line segments to make an angle. Some line segments can be really, really small. For example, right over here, I have a piece of basmati rice. It has a beginning, it has an end, it's a line segment. I could have one that's a little bit bigger. Right over here, toothpick. Again, it's straight, it connects 2 points, it has a beginning and an end. It's a line segment. Sometimes line segments are a whole lot bigger. I've got here several 12-foot pieces of lumber. These are each line segments. They have starting points at one end and they have ending points at the other end. They're a straight distance between 2 points. So these are line segments. All right, you ready to see one really big line segment? I'm in one end point right now. And now, here I am at the other endpoint.
Let's take a look at the path that I drove down Simsbury Road. So on this map, you can see that I'm in a straight line from my starting point to my ending point. That means that I've got a straight path connecting 2 points, which makes this 1.5 mile drive a line segment. So now let's talk about rays. Rays, like line segments, are straight and they connect 2 points. So if I draw some points right over here, I think we left off on O and P. So here's going to be point O, and this is going to be point P. They are straight, they connect 2 points. The difference is that they have only one end point. They have what one could call a beginning, but no end. So let me show you an example. I use my ruler, make sure I'm going to be nice and neat. And you always have a ray, you express it with an arrow at one end. So you'll notice that this begins at point O and it doesn't stop at point P. Rather, it continues through point P, and that's what this arrow symbolizes. The idea of it having a beginning, an end point here, but no end. It doesn't ever stop. It begins and then it continues on, and that's forever. Some people might say, oh yeah, it continues through point P and it stops here. No, if it stopped there, it would be a line segment. The idea is that this arrow represents the idea that it's going on forever and ever. No, that doesn't just mean to here. That doesn't just mean to here. That doesn't just mean to here. That means forever and ever and ever. Miles and miles and thousands of miles. Forever. It never ends. And for that reason, when you have a ray, you can't ever measure it. I don't want you to look at it and say, oh, hey, this ray looks to be about 3¼ inches. That's not true. You can't measure it because it goes on and on forever in both directions. Whereas a line segment, you certainly can measure. We can look and say this is about 2½ inches. Or line segment GH is about 3 inches. Line segments you can measure. But rays, they have no length. It's unlimited. You can never hope to measure it. In terms of naming a ray, you always begin by its endpoint, where it begins. So this is ray OP, because we begin with the endpoint and we finish that with the point that it travels through as it continues on forever. And we put an arrow on the top to symbolize the fact that this is a ray. Again, starting at point O, there's the beginning of my ray by point O, continuing through point P. That's why the arrow is above the P. Let's take a look at some other examples. I can draw a ray that goes down this way. And we're going to say that it begins in point Q, and it goes through point R. So I can name this. The first letter that I'm going to put down is going to be a Q, because that's our origin. That's where it's starting. And then it's traveling through point R. And I put my arrow on the top. Again, beginning at point Q, traveling through point R. Sometimes it can get a little confusing. Let's look at one other example here. Let's name that point S and point T. You might think that this should be ray ST because on the left is S and on the right is T, but that's not the case. Again, remember, we begin by naming it with its beginning, so the T is going to come first, and then we finish naming it with the point that it travels through as it goes on and on and on forever. So in this case, we have ray TS. We start with the beginning, that endpoint, and then we finish with the point that it travels through. So we have rays OP, rays QR, and rays TS. And these are different ways to represent the idea of a ray, something that has a beginning but no end. Let's look to see if we can think of some real world examples of what a ray is.
So we know that a line segment is something that's straight, it connects 2 points, and it has a clear beginning and ending. But a ray is a little bit different because a ray is a beginning, but then it goes on and on and on in the other direction forever. And that's the hard part, the idea of forever. Forever doesn't just mean for a really long time, it means forever. And coming up with a way to show that, that's the tricky part. But I have a tool here that's going to help me out. This is not your average laser pointer. This is a very, very powerful laser. It's so powerful that if I were to shine this in somebody's eye, it would cause blindness. And that's one reason why this laser comes with a set of keys just to protect it. This is an incredibly powerful laser, and it can travel many, many miles just in a single narrow beam of light. So let me show you. I'm just going to shine it right here. You may not be able to see the laser beam on camera, but I'll make sure that you can see it more in a moment. But if I turn it on right now, you can see that it starts right over here. Maybe you can even see the reflection in front of my hands here. It starts and it's traveling straight down to the surface of my deck. And right there, this is not a ray because it has a beginning right over here and it has an ending point right down there. This isn't a ray, this is a line segment. But this laser pointer has the potential to give me a ray. Now I can go a little bit further. I can go and I can shine this across over onto my neighbor's side of my neighbor's house here. And again, you can see it's a very strong beam here, so it can travel. We can just kind of sort of see it. It's easier to see it in real life. But again, it has a start right here in the laser pointer by my hand, and it has an ending that you can see on the side of my neighbor's house. So again, this isn't a ray, it's a line segment. Now, I could go even further. I have a tree right over here. I don't want to shine this just right into the sky. That wouldn't be safe because if a bird were flying, it could actually blind the bird, and we don't want to have that happen. If a pilot were flying, it could actually reflect up in their eyes and cause blindness, and we certainly don't want to have that happen if somebody's in the middle of flying an airplane. So we're going to be safe with a laser because lasers are tools. They're not toys. So I'm going to simulate the idea of this. I'm going to shine it into the tree, and I'm going to be sure to aim it right at the tree trunk. Now, I don't know if you can see this, but I'm shining it kind of diagonally here into the sky. But if you can see that bright green point in the distance, that's my laser beam hitting the tree trunk. Again, that means that I've got a line segment because it's starting in my hand and it's ending when it hits the tree. Now imagine for a moment that I did shine this up. Imagine that my hand wasn't here and that I was actually shining this laser into the sky. Then it would have a starting point right here in my hand, but it wouldn't necessarily have an ending point because it would just keep going up and up and up. It would go through the clouds. It would go through the Earth's atmosphere. Yeah, it would be getting a lot dimmer at that point, but even a dim laser beam, it would still be going higher and higher and higher and further and further and further. So is that a ray? Technically not. Because here's what's going to happen. Even though a very faint version of this beam is going to get up through the sky, through the clouds, through Earth's atmosphere, eventually, this beam here is going to hit something. It's going to hit a moon, a planet somewhere, a star, an asteroid, a comet, a meteorite, an alien ship, I don't know what. But eventually, it's going to hit something. And remember what I said before. Going on and on and on and on and on and on and on for a really long time is not the same as going on and on and on and on and on forever. So even though we'd like to think that this laser pointer can produce a ray, a start, but no end, the reality is it probably can't. Eventually it's going to hit something. So the question is, what in the real world can we use to really represent the idea of a ray, something that goes on and on and on forever in one direction, a starting point, but no end? Again, that's a tough one. The rays of light coming from the sun? Sure, it could work. I know it's nighttime now, but the rays of light come from the sun, but then they come and they hit the grounds of the earth. And that's the end. So it's a line segment. Or they travel in another direction and they hit the moon, or they hit something else. Same problem. So what's a real example of a ray? I don't have one.
Now let's learn about lines. Lines, remember, in the world of geometry, have a particular meaning. It's not just a line on a sheet of paper. It has a particular meaning. So we know that lines, like the other figures we've learned about, are straight and they connect 2 points. The difference, though, between lines versus rays or line segments is that they continue on forever in both directions. There's no beginning and there's no end to a line. So if I draw here points U and V right here, I'm going to draw my line that goes through both of these points. I put an arrow on both sides to show the idea that it continues on in this direction and it continues on in this direction. And the thing that I want you to remember is that it continues on, again, this key word, forever. It goes on and on and on. It has no ending. It's not as if it goes to here. Doesn't go this far. It goes all the way off the page and beyond. It continues on forever. And again, in this direction, but also in this direction. They go on forever. We can name it using points U and V with a line on above it with an arrow on each side. Because it's almost symmetrical and that both sides extend forever in both directions, I could also name this line VU. Let's take a look at another example here. I'll draw this one perfectly horizontal and add my points. And by the way, they don't even have to be spaced out. I could add it this way. W and X, yeah, they're really close together, but for whatever reason, I drew it longer like this. That's fine. It doesn't really matter. I could have put my arrow here and stopped here because we know that it just goes on and on and on forever. So sure, put the arrow here, put the arrow here, put the arrow off my paper, put this arrow here or further to the left of it. It doesn't matter because, again, it goes on and on and on in both directions. I can name this line WX or line XW. So lines are straight, just like everything else. They connect 2 points, but they go on forever in both directions with no beginning and no ending. Boy, we seem to be having a hard time coming up with real world examples of rays. If those were hard to show in real life, a line, something that goes on and on and on forever in both directions, that surely must be pretty tough. Let's see what we can find. When people are trying to think of a real world example of a line, they often think of the equator. The equator, as you may know, is a band that runs around the outside of the Earth, right in the center, in between the northern and southern hemispheres. You can see it right here on this map. People often think it's a line because, as you can see on here, it looks like a line, it appears straight, and it has no beginning and no ends. It just keeps on going. However, there are 2 other parts of the definition of a line that this doesn't quite meet. One is the idea that it connects 2 points. And yes, you could say that any of the places along the equator could be considered a point. That's true. The other issue is that it doesn't go in a straight path. It looks straight from this angle on the map, but if I change the way that we're looking at the globe, you'll notice that the equator is in fact a curved line, and that as the Earth rotates, it's a curved line that goes around the Earth. It's a circle. Well, that tells us that it certainly cannot be an actual line in the eyes of geometry. In fact, the only example I can really think of for a true line in the real world, and I know this is a bit of a cloud, is the number line. The number line, as you know, can be straight, like you see right here on my screen, and it can go on and on and on forever in both directions. I can go on and get some larger numbers, or I can go and get some smaller numbers. And I can show how far it travels outward because I can change the scale of my number line. Here we are working at hundreds. We can also go on and on and on, zooming out here. Now we're working with thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions. You get the idea. It just keeps on going forever and ever and ever and ever. Really, folks, a number line is the only true example of a line that I've ever been able to think of. But if you can think of another good example, please share it. Let's see if we. So let's take a moment to review what we've learned. Right here, I've drawn something. Please tell me what we would call this figure. And now I've drawn this. This is another point. So we have point Y or point Z. Tell me, is point Z larger than point Y? In fact, it's not. We know that points don't have any size, they don't have any shape, they're just locations on, in this case, a sheet of paper. So I've got point Y and point Z. I'm going to connect them now. Could you please tell me what we would call this particular figure? This is a line segment. We could either call it line segment YZ or line segment ZY. Now let's change this up a little bit. Let's have it extend a little bit in one direction. Now, what do we call this figure? This is ray YZ. We wouldn't call this ray ZY because we always start with the origin point when we name a ray, and we finish with the point that it continues through on its path to going on forever in that one direction. Let's try a different way to identify this or to represent this. Please tell me how we would identify this figure. This is a line, and we can call this either line YZ or line ZY. It doesn't matter because it's the same in both directions. It goes on and on and on. This is a line. The last thing that I want to do is just to introduce you to the idea of the fact that sometimes you'll have a line or array or a line segment or a combination of more than one, and they're going to come together and meet and form that point where they connect. So for example, I have line YZ, and now I'm going to have another figure, and gosh, I'm going to start again. We'll call this point A. I have line YZ and line segment YA or AY. They're meeting and they're forming what we call an angle right in the middle. An angle is the point in which two line segments or lines or rays, or in this case, a combination of both, where they meet. We're going to learn about angles in another video. And we actually have an angle here, but we have another one kind of on the outside right over here. These are angles, and they're points in which these figures meet. This has been Mr. Moss working with you on learning about lines, line segments, rays, and points. And I hope this was a helpful guide for you. Have a great day.